All right, we're going to talk about condensing logs, and we're going to talk about the three main laws of logarithms. Okay? There are three main ideas that we're going to over and over again use. And if you don't know how to go back and forth between both forms, you're not going to do a whole lot. Oh well. So, the first one is our product law. And that tells me that log base, okay, b, of m plus another log base b of n is equal to, aka we can change, we can manipulate this form to be log base b m times n. Okay? If you are adding and they ask you to condense it, you need to multiply that sucker together like I just did with this right here. You need to be able to see that. You need to go back and forth between both forms, but this right here would be the condensed form. This, over on the left side, is our expanded form. Okay, expanded form, condensed form. Okay, so let's continue on. The next log is when, hopefully by now you'll be like, oh, it's going to be subtraction. I hope so. Equals log base b m divided by n. We divide. Condensed, expanded. Condensed, expanded. Okay? Look. Condensed, expanded. Alright? You need to make sure you understand that. You can write them either ways. Most of the time, we want to be able to condense it so we can solve. So here we go. The last but not least is when you have, n log base b of m. Okay? When you condense it, it will become log base b m to the nth power. Okay? I like to tell you guys, if you pay attention to me, take this, circle it, and point to it. It goes right there as the exponent. Alright? Those are the three things we are using. Okay? There's one other property that we're going to talk about, but I'll talk to you about it when we get to an example. So, with that being said, let's look at some examples. Alright, here are some examples of the logs that we can condense. So, the first thing I want you to see is more traditional. It's like the property, so you shouldn't, or the law, so you shouldn't have a hard time figuring this out. We know it's adding, so we're going to take the log base 6, and we're simply just going to multiply, okay? W times x. All right? That's it. That's all I want you to do. We are condensing down to one log, okay? One log, ln. That's what we want. We just want one. We don't want 5. We don't want 7. We want just simply one log, okay? So, number 2, we do the same thing. We need to condense these two logs down to 1. They have the same base, so we're good to go. This one, though, we have a coefficient. I told you the coefficient. You draw a circle and point it to your x so that you know it's an exponent. So, we still have addition, so we're still going to be multiplying. Log base 13 x squared, okay, put some parentheses around there, times z. Done. Okay? This next one, we have a coefficient. Whoop, put it up there. Now, look at this. We have a whole big thing. That's okay. Don't freak out. It's fine. Okay? Just got to make sure you just take it one step at a time. Have another coefficient. This time, we're subtracting. What did I say subtraction was? Subtraction is going to be this property right here. We're going to divide. Okay, so let's be very careful how we do this. Log, all right, W minus 2, I'm going to put that in parentheses, all raised to the 4th power over x squared. Now, I ran out of space, so you're just going to have to listen to my voice to make sure you understand that. Parentheses on top, W minus 2 to the 4th power, all over x squared. Do not put the 4 on the outside. It's just simply a part of this argument, this one, okay? It's just a part of that argument, all right? Those are some examples of condensing. The next thing we're going to look at is examples of expanding. Now, the reason why we expand, okay, the reason why we expand is so that we can, it is useful for pre-calculus. So if you're going to pre-calc, it's very important that you understand how to expand, because there are certain logs that you can get that are nice properties that will equal 1, equal 0, so you just got to pay attention, okay? Now, for my Algebra 2 folks who are not going to be taking pre-calculus, you're just going to have to be able to understand that logs can go both ways. There are 2 ways that you can go, okay? You have this way, which is the expansion, and then this way, which is the condensing. You need to understand both ways. Backwards, forwards, inside out, okay? All right, I wrote down some examples, so let's get started. This one, the first one, number 1, we notice that they're all multiplications, so that means we're all going to have plus signs, all right? Log x plus log w plus log t. That's it, okay? That's all you got to do. That's it expanded. This next one, we have an exponent. Whee! And we have a division symbol. So that means we're going to be subtracting. So 2 ln x minus ln 3. Yay for examples that work. Okay. As we continue forward, this one, the example number 3, we got a lot going on. We have this, which is going to become a coefficient. Then we have the square root symbol and a 4th root. I know that's hard to rationalize, but we need to understand that when we have a square root, it is also saying that we have x to the 1/2, and this one's also saying that we have y to the 1/4, okay? There's an understood 2 here, so we can write them as fractions. Square roots, cubed roots, quartic roots, any type of roots, any nth roots can be written as a fraction in your exponent, okay? So let's expand this. We're all multiplying, so I left that kind of easy for you guys to see. So we just simply need to rewrite it, okay? 4 log base 6 of r plus, now we handle this square root of x, okay? I just told you it's 1/2, so you can write 1/2 log base 6 of x plus 1/4, excuse me, my children just came home, 1/4 log base 6 of y. That will be it expanded, okay? That's the expanded notation. And that's a short, brief lesson on expanding and condensing.